Hello everyone. As a group of 8, we will be presenting a demonstration on the operations and functionality of a permeameter. But before that, let's have a short introduction. So, what is permeability? Permeability is a property of soil that allows water to flow through it from points of high to low energy due to the presence of interconnecting voids. The permeability coefficient K measures the degree of the permeability. Two general laboratory techniques can be used to find a soil's permeability. The methods are the constant head method used for highly pervious soils and the falling head method used for intermediate and low pervious soils. When water can easily pass through the soil, it is said to be highly pervious. When water cannot pass through the soil due to the impermeable soil, it is said to be extremely poor permeability. Since we are using beach sand sediments, which are mainly composed of coarse grained fragments, we will be demonstrating the constant head permeameter.
So for the permeameter design, we have gone for this. We have used a 4-inch diameter PVC pipe that is 1 feet in length, which will serve as the main chamber where the sediments will be held. The purpose of the permeable discs will be fulfilled by what we are using are steel bowls, which will help to make sure that there is no sediments flowing through the outlet or into the inlet. For the inlet and outlet, however, we have used half-inch PVC pipes, inlet located at the bottom and outlet at the top. This is done in order to maintain a more of a steady state flow throughout the sample rather than an undistributed flow through the sample, which would be the case if the inlet was at the top and the outlet at the bottom. The purpose of manometers are fulfilled by plastic tubings which are supported on a plastic corrugated sheet, and all of the sealing work done is done by using M.Sc. So by using minimal amount of things, we can prepare a permeameter at home itself. And since this is a constant head permeameter, a reservoir where the head will be kept constant will be used, which will be shown in the actual working setup.
So I will be explaining the principle, limitations and the applications of the permeameter. So the permeameter works by creating the pressure difference between both ends of the saturated soil samples, and it measures the flow of water between it, by which we can determine the permeability of the soil sample. Now the applications of permeameter. So the permeability determined by the permeameter can be used to extract the oil from the reservoir. It is used in geotechnical for the subsurface structures like the embankments. It is used to see which layers obstruct the drainage pattern by measuring its hydraulic conductivity and permeability. It is used to check the gas drainage in the coal seams, and it is used to check the suitable recharge of aquifer. Now the limitations of permeameter. It can underestimate the saturated hydraulic conductivity of highly permeable media, and it get more severe the more the hydraulic gradient. Higher the permeable media, more there will be non-Darcian flow in the sample, and very less fine grain sample have very low discharge. That's why it's not used in fine grain materials.
We have a plastic tank which operates as a reservoir, and the nozzle is replaced by a plastic pipe. So the water will be supplied to the apparatus. As we are using a constant head method, if the water in the tank will decrease, we'll open the tap and will fill the reservoir till March if required. The material medium used for the permeability experiment is a sand. The sand is collected from Uran beach in Raigarh. The sand is poorly sorted and coarse-grained. Approximately 3.5 kg of sand was collected and is sandwiched between the two steel balls inside. The steel will act as a permeameter disc. Now we shall begin the experiment. serve the purpose of indicating the pressure levels of the top and the bottom of the apparatus. Now, to measure the pressure difference, we consider the head difference between the upper mandibular and the lower mandibular. This measurement is done using a measuring tape. Difference in the head between the lower mandibular and the upper mandibular is 4 centimeters. So this is the measuring cylinder we are using. It will collect the water. Just start from the permeameter in unit time. Now we will proceed with the
calculations. So to know the coefficient of permeability, that is K, we have the formula Q into L, the whole divided by A into T into delta H, where Q is the amount of water that is collected in a measuring jar for a time interval T. L is the length, is the sample length across which delta H is measured. Delta H is the hydraulic head difference, which is measured by subtracting the water level measured in first manometer minus the water level measured in the second manometer. A is the area of cross section that is measured, for which we should know the inner diameter of the permeameter, and T is the time interval. So the data we are collected for this experiment. Q measured was 1530 milliliter. L, length across which the sample length is 40 centimeter. A is the area of cross section, which comes up to 66 square centimeter. T is the time interval. So over here we have taken 3 minutes, which when converted into second gives us 180 seconds. Delta H is 4 centimeter, and Q is so over here everything is in centimeters. So to convert milliliter into centimeter cube, we have 1 milliliter equals to 1 centimeter cube. So we get Q is equals to 1530 centimeter cube. Now putting all of this value in the formula and calculating it, we get the answer as 1.28 centimeter per second. So the permeability coefficient of the sample we have taken as is 1.28 centimeter per second.